All right, folks, good morning. All right, so here, this is going to be the first cool down that we went over. Had a few questions here, four to be exact. Usually like to keep it around there. And I'm going to spend this time answering each question one by one and actually reviewing the cool down itself. I feel we've had enough time to get ourselves acquainted with the cool down, read it, go over it with our teammates, and uh, even submit it at some point, right? So I feel right now is the perfect time that before we see this question in some way, shape, or form on our upcoming final, to go over it in detail. So here we go. Reason I had the laptop up there so you can see that everything I do here is to answer that particular question. So you're not going to see me copy the question down word for word. Rather, just go ahead, get to it. So that document is viewable on both the Nearpod asynchronous codes and the codes I will be providing, or the links, I should say, to the forms during class. So without further ado, let's begin. Okay, so this question is asking us that outside of the United States, the common paper size is called A4 and measures 21 by 29.7 centimeters. So we're looking at a rectangular piece of paper. And it has a function, V of x, which is the volume in cubic centimeters of a box made from A4 paper by cutting out squares of side length x in centimeters from each corner and then folding up the sides. The question that it's asking from this scenario is, what is a reasonable domain for V in this context? And then explain your reasoning. So let's go ahead and look at how it was structured as a Google form. So we got V of x. V stands for volume. I'll label everything right now. And volume, as we know, is the product of three factors: length, width, and height. We can think of them in this order. So that's not to say that this couldn't be the width, but for simplicity's sake, we'll just go in that order. Okay, so we got 21 minus 2x as our first factor, our first dimension, 29.7 minus 2x as our second dimension, and then the third dimension is just x by itself. Okay, so the first question is going to ask us, what do those things represent, those factors, those dimensions? They represent length, width, and height. Okay, if you label this length to begin with, and then after some calculations, you figure out this is the length, no harm done. So these can interchange, and at the end, you can kind of just verify which one's which by figuring out the exact values. But for the most part, just know that these three represent length, width, and height in some way, shape, or form, right? There you go. The next question then asks, the value of x must be greater than what? Okay. So we could look at this x or this x here, but to keep things really simple and honest, it's this x that you're most concerned about right here, this third one. That x needs to be bigger than 0. Here's why. Let's say you have figured out what the length is, and the length is like 7. Figure out the width is 5. These are just imaginary number, arbitrary, I shouldn't say imaginary. These are arbitrary numbers, just random numbers to illustrate a point. Now let's say this one is equal to 0. Well, if you multiply 7 times 5, that gives you 35. Bring the 0 down. So now you have volume is equal to 0. Okay. And this would be with an x value of 0. So I'll replace that. This doesn't do anything to the calculation. It's just symbols or notation to signify that the volume, which was in terms of x originally, now is in terms of 0. So if I plugged in 0, it gave me this. If I plugged in 0, it gave me this. This is just arbitrary numbers. Okay? It's not necessarily true what these two are. But what is true, though, is that whatever these two are, we can even just replace them with letters, to be honest. Let's say it's length times width. okay, and length and width, multiply them together, it gave you 35 for whatever reason. And then the height is 0. Well, you're gonna end up with a volume of 0, right? So that means there is no box. And the whole point of this problem is to design a box. Well, if you have no box, then there's nothing that you're gonna be designing. It's thin air at that point. Okay, so that's why x needs to be larger than 0. So you're probably thinking to yourself, what about negatives? Would negatives work? All right, let's try -1. Okay, -35 would not work, ladies and gentlemen. Any negative, you can substitute for yourself. If you did -2, that'd be 35 times -2, which is -70. You can try a bunch of negatives, but you're gonna keep finding that as you keep going down the negative path on the number line, progressively larger and larger negative numbers will just get larger and larger negative volumes, and negative volumes do not exist. Okay, so that's why you cannot have 0, and that's why you cannot have negatives. X needs to be larger than 0. All right, let's go ahead and hop into the third question. The small side we select for calculations is, and the large side. Oh, it doesn't ask for the large side, but why not? Just label it while we're at it. Okay, so this is quote unquote the small side of the rectangle. And then this one is the large side of the rectangle. Okay, now a reasonable domain occurs for V when. So how do we actually find that reasonable domain, right? Well, we need to think to ourselves, if I grab the smallest side, which is 21 minus 2x, I need to tell myself that this needs to be greater than or equal to 0. This entire factor, just like we discussed here, that x must be greater than or equal to 0, this one factor was only x. Well, this factor here, it's not just x, it's an entire expression, 21 minus 2x. So we need to come to the agreement that it needs to be bigger than or greater than 0. I might even argue it just needs to be greater than 0, because if it's 0, we already know what that issue ran into over there. So this is how I'm going to go about it. That's how I think. Now, this sign, which is greater than, you can imaginarily, you can imagine that it's an equal sign when you're operating with it. If that makes you uncomfortable, it's the same thing as dealing with an equation. When you deal with an inequality, when you're adding stuff and whatnot. All right. So we're going to do ourselves a favor here. We're going to subtract 21 from both sides. Now we're going to divide both sides by -2. Now here's where things get a bit tricky for us here. When you divide by a negative value on an equality, it will change the sign of the inequality value. It flips it over when you divide by a negative. And here we are divided by a negative. So when you divide by a negative, switch it. Okay. 21 divided by 2 is 10.5. Negative divided by negative is a positive. Okay, so our first restraint that we discussed earlier in this video is that x needs to be larger than 0. This next constraint, let's call it constraint because it's telling you you have to constrain yourself. You have to have a limit. You cannot go beyond this value, so you have to constrain it. So you have to constrain x to be no larger than 10.5. And the earlier constraint from earlier that we wrote down tells you need to constrain x to be larger than 0. So now this new constraint says that x is between 0 and 10.5. I'm just checking if it's going to come out or not. Yes, we are in business. I don't recall the units. I think it was centimeters, but I'm just going to write units down. Whatever it was, you can just replace the word units with whatever particular measurement was used. All right, so that's everything you need to know about Cool Down 2.1. Good luck.